problem. The review on antimicrobial resistance was a great success, and, alongside a drive from the UK government and many others from the public, private and philanthropic sectors, it helped to galvanise international action at meetings of both the G20, Group of 20 Developed and Emerging Economies, and the United Nations General Assembly in 2016. These forums have raised awareness of the issue to the highest level. But we must recognise it is just the beginning. I will continue to do all that I can to achieve progress, including through the newly established ad hoc UN Interagency Coordination Group on Antimicrobial Resistance, of which I am a convener. This book is a vital contribution that clearly articulates the case for action and, crucially, how to do it. At the core of addressing drug-resistant infections are a number of economic challenges which must be surmounted. Superbugs has the promise to bring these economic policy solutions to a wider international audience, raising public awareness and helping to stimulate action. It also makes a convincing case for policymakers to take the next steps, and contends that we have reason to be optimistic if we are decisive now and address this complex problem with sufficient resources. We must act soon. Otherwise, this terrible problem will continue to worsen, and we will leave the world in a much poorer state for our children and grandchildren to come. Introduction. Bacteria live inside all of us. On average, every human body contains 100 trillion bacterial cells, 3 bacteria for every human cell. If all of these bacteria were removed, we would each lose about 2 kilograms, 4.5 pounds, in weight. Thankfully, most of these bacteria are either benign or play useful roles, such as helping us digest food. However, some of them that might be harmless in our nose or gut can be lethal in our lungs or bloodstream. Other bacteria that are not normal inhabitants of the body can also infect us, causing diseases such as tuberculosis and diphtheria. For much of human history, these kinds of bacterial infections were some of the world's biggest killers, claiming huge numbers of lives. During the late 19th and early 20th centuries, we became much better at preventing infections, but doctors still remained powerless to treat them after they started. This changed in the 1940s when penicillin, the world's first modern antibiotic, became available. Patients who had been near death were able to return to full fitness just days after taking what was often called a miracle cure. But the miracle did not last. Unlike the situation in almost every other area of medicine, antibiotics became less effective the more they were used. In response to the onslaught of penicillin and other antibiotics, drug-resistant bacteria with characteristics that protect them from attack, survived and thrived. Bacteria have now become resistant to many of the drugs in our current arsenal, and fewer new drugs are being produced. We have reached the point where scientists are warning that we face one of the greatest threats to humankind. Not only could many common infections become incurable, but a lack of effective antibiotics could effectively end much of modern medicine, since we rely on these drugs to keep us healthy during surgery and cancer treatment. A sobering example from 2016 provides a glimpse into a possible future. A woman in a hospital in the United States had a bacterial infection in her leg that was completely resistant to every available antibiotic. 26 in all. Nothing further could be done to treat the infection. Despite having access to one of the best healthcare systems in the world, the woman eventually died. In 2014, Sally Davies, Chief Medical Officer for England and author of this book's foreword, convinced Prime Minister David Cameron that the United Kingdom needed to take a leadership role on the issue. Cameron commissioned an economic review on antimicrobial resistance to look into the problem.